So here we have a question 1, and 1.1 says, given the sum to n terms of an arithmetic sequence. So we have Sn is equal to 3n squared minus 5n. Now, even though it doesn't look like it because we've got n squared and another term within, it is arithmetic since they've mentioned that, okay? And here is the sum. 3n squared minus 5n. 1.1.1 says, calculate the sum of the first 21 terms of the sequence. So we need to calculate S21. So this is quite simple to do since we are already given the sum formula. All we need to do is, in this formula, we are going to substitute 21 in place of n. Okay, so doing so, that is going to be S21 is equal to 3 into 21 all squared minus 5 times 21. And all you have to do is just plug this into your calculator. That should give you 1218. Now, 1.1.2 says determine the 22nd term of the sequence. So I have shown you guys how to do this in a previous question, in a previous video, and there is a specific formula that we use for this. So if you are given the sum formula and you need to calculate a specific term, it would be the sum of that particular number minus the sum of the previous number. And what I mean by that is, for example, say that you need to calculate term 10 and you only have the sum formula. To do that, you would have the sum of 10 terms minus the sum of 9 terms. That is how we do this, okay? So seeing that we need to calculate the 22nd term, applying the same formula, it should be S22 minus S21. And logically speaking, that makes perfect sense, because if we add up 22 terms of this pattern, the first 22 terms, and we minus the sum of the first 21 terms, that difference is going to give you the 22nd term. So this is something that you should know, this formula specifically, whenever they ask you to calculate a specific term in the pattern and you have the sum formula. This is the rule that you're going to apply. Okay, to answer this question, it is going to be S22 is equal to, actually T22 is equal to S22 minus S21. Now, I mean, you can calculate S22 and S21 separately and then substitute in here, but I'm just going to do it all in one. So it's going to be, if we just remember what the formula was, 3n squared minus 5n. So it's going to be 3 into 22 squared minus 5 into 22, and then minus S21. But remember, we had just calculated S21 in the previous question. So it should actually help if 1.1.2 said hence calculate the 22nd term. Then that would actually remind you that you needed to use the previous answer. But it's okay, I mean, we have this formula that we're going to use anyway, so we didn't really need the reminder. Now, if we calculate S22, that is going to give you 1,342 minus 1,218. And the difference between these two gives you 124. That tells you that term 22 is equal to 124. Now, 1.1.3 says how many terms of the sequence must be added to obtain a sum of 8,162. So we want to know how many terms must be added. They are asking you, how many terms are you adding? Meaning, what is n? For example, if we were adding 50 terms to get this value, then we know that n would be 50. That's just an example, right? So we need to figure out what exactly is n. And the good thing here is that we have the sum formula, so all we have to do is equate it to 8162 and solve for n. So I'm going to say 8162 is equal to, it is 3n squared minus 5n. You could even write it the other way around. You could have 3n squared minus 5n is equal to 8162. It means the same thing. Now, immediately we notice that this is heading towards being a quadratic trinomial. So to get it in standard quadratic format, I am going to take that constant over to the right. It's going to become negative 8162. Now here I identify A as being 3, B is negative 5, and C is negative 8162. To solve for this, we are going to apply the quadratic formula. Okay, let's substitute B, which is negative 5. A is 3. C is negative 8162. All over 2a, so that's going to be 2 times 3. Now, one thing I always encourage my learners to do is, whenever using the quadratic formula, I always encourage them to simplify what they have. So simplifying my first term, I've got negative times negative 5, which is going to give you positive 5. The next thing we would simplify is underneath the square root. So if we put all of those values that we have underneath, that is going to be 97969. And denominator 2 times 3 is 6. So the reason why this is encouraged is because it leaves less room for error. Sometimes when you are putting the entire quadratic formula onto your calculator, it's very easy to make a mistake. So that's what we're trying to avoid. And now when you put this on your calculator, let's work with the plus first. We get n is equal to 53. And if we use the minus, we get n is equal to negative 51.33. Now from what we know, n cannot be negative. We don't have negative term numbers, okay? So immediately we're going to say n is not equal to negative 51.33. And just to remind you of what the question actually asked you to do, they said how many terms of the sequence must be added to obtain a sum of 8162. And we had an answer of 53, meaning that 53 terms have to be added to get, which means that we are adding 53 terms together to get that sum of 8162. So we can conclude that we are adding 53 terms. Or you could write it as S53 is equal to 8162. Okay, let's go on to 1.2. It says consider the sequence 7, 7, 7, 12, 7, 17, 7, 22. Just by reading this out, I noticed that every alternate number is 7. So notice, there it is. So what we notice here is that these are all the odd term numbers. So all the odd terms are 7, meaning that the odd terms form a constant pattern, okay? And if we focus on the even terms for a second, so that is going to be term 2, term 4, term 6, and term 8. We've got 7, 12, 17, 22. We notice that those terms form an arithmetic pattern because we are adding 5 each time. 7 plus 5 gives you 12. 12 plus 5 gives you 17. 17 plus 5 gives you 22. And this pattern is continuing in that manner, where every odd term would be 7 and every even term would be the arithmetic pattern. So that is something that they would expect you to notice on your own. Now 1.2.1 says determine the value of the 78th term of the sequence. 78th term, meaning that if this pattern were to continue and we have term 78, what would it be? The first thing I want you guys to notice is that term 78, that is an even term, meaning that it is going to be part of the arithmetic pattern. So it's going to be an arithmetic, a term from the arithmetic pattern. Now, another thing I want you guys to take note of is that since half of this pattern is arithmetic, when we talk about term 78, if we are going to isolate the arithmetic pattern itself and just look at those values, 7, 12, 17, 22. So leaving out all of the odd terms, all of those constant sevens, the arithmetic pattern forms half of this pattern, meaning that if we focus solely on the arithmetic pattern, where we've got 7, 12, 17, and 22, and I now focus only on this as my terms, term 1, 2, 3, 4. Term 78 here, it's no longer going to be term 78, but in this pattern alone, it is going to be term 39. Now how we get that is 78 divided by 2 is going to give you 39. Now the reason why I'm saying term 39 is because 50% of that pattern is arithmetic, meaning that only half the terms are going to be arithmetic. So when we talk about term 78 itself in this whole big pattern, when we focus on the arithmetic itself, it's only going to be half of that. So it's going to be term 39. Okay, so that's something that you have to take note of. So the approach that we can use here is, I would suggest getting the general term. Once we have the general term, we can substitute 39, and that would give us basically term 78 from the big pattern. Okay, so this is 1.2.1. Tn is equal to a plus d into n minus 1. My first term here is 7. We are adding 5 each time. Let us get the general term. So distribute the 5 into the brackets, and we've got 2 plus 5n. So this is our general term. Now we want to get term 39, so we're going to substitute 39 in place of n. And if we just quickly calculate that, that is going to be 197. Now we have already established that in the arithmetic pattern alone, term 39 is the same thing as term 78 in the entire pattern. So now we can conclude and say, therefore, term 78 is going to be 197. And this is actually something that is commonly done in grade 12 number patterns questions, where they take two separate patterns and they fuse them together. And especially when you have that kind of situation, you need to remember that 50% of the terms belong to one type of pattern and the other 50% belong to the other type of pattern. So this is especially important when we have questions like 1.2.2, where it says calculate the sum of the first 103 terms of this sequence. The first 103 terms of the sequence. Now to understand this, I just want to break it down further, okay? Actually, I just want to talk about having 100 terms, for example. Say that they asked you for the sum of 100 terms. We would understand that 50 of those terms are sevens only. and the other 50 of those terms are arithmetic. However, we are asked for 103 terms. Now, just to put this into perspective for you, term 103, this is an odd number, okay? So understand that term 103 is going to be 7 because those odd terms are 7s only, okay? So if we were to take 102, because that would be the one before that, right? If we were to take 102 terms, 51 of those terms would be 7s, and 51 of those terms would be arithmetic. However, we have 103, meaning that there are going to be 52 terms that are 7s and 51 terms that are arithmetic. That is extremely important for you to understand in order for you to be able to answer 1.2.2. Okay, so here is that information that I've just mentioned. 52 terms are constant, right? So it's a constant of 7, and 51 terms are arithmetic. Now let us get the sum of each of these separately, and then we can fuse it together to give us the sum of 103 terms. So I'll start off with the left-hand side where I'm getting the sum of 52 terms. Since they are all going to be 7s, 7, 7, 7, 7, 52 times. So to get that sum, we can just say 7 times 52. And that is going to be 364. So that was quite basic because it was a constant value. However, for the arithmetic side, it is not going to be that simple. We will have to use an arithmetic sum formula. So let's go with Sn is equal to n over 2 into 2a plus d into n minus 1. Here we are getting S51. So n is going to be 51. The first term was 7. The constant difference is 5 into 51 minus 1. And once you calculate this, you should have 6732. Now all we have to do is add both of those sums together to get the sum of 103 terms, which is going to be 364 plus 6732, and that should give you 7096. So you guys, please take note of questions like this where we have two different patterns fused together, as they are extremely common in grade 12 papers.